This video was sponsored by Brilliant.org. To learn more about the natural world through solving problems, go to brilliant.org/Simon Clark. The Marvel Cinematic Universe, or MCU, is an unprecedented achievement of franchise filmmaking. Across 22 films and 11 TV shows, the MCU ties together hundreds of characters and plot lines, weaving a hugely complex tapestry that is somehow still understandable and ultimately emotionally satisfying in the recently released final part, Endgame. This video will contain no spoilers, incidentally, so no need to stress. One of the most striking aspects of the MCU is the setting of many of its stories, ranging on Earth from America to Wakanda to America to Germany to America to Nepal to America.
But beyond Earth, the MCU showcases some fantastical worlds, some similar to Earth and others which are incredibly alien.
Who are you?
Dr. Hannah Wakeford is a planetary scientist at the Space Telescope Science Institute and an expert on planets orbiting other stars, exoplanets.
I like this one.
In this video, using her PhD in exoplanetary science and my PhD in atmospheric physics, we're going to review every planet shown in the MCU to determine which ones could really exist.
First of all, some ground rules. We will only be using information from the films in the MCU, not the comics.
Yep. No thanks.
We'll be determining if the planet could exist as they are depicted in the films. That means both physically and also biologically if that planet is shown to be habitable. We're going to do this by comparing the MCU's planets with planets and exoplanets that we've discovered, as well as the laws of planetary and atmospheric science.
So, with these rules in place, and 28 planets, moons, and astronomical objects to consider...
Are you ready?
The MCU kicked off in 2008 with Iron Man. The only planet to feature was our very own Earth, so yeah, that could definitely exist. Iron Man was followed by the mediocre Hulk, which again only featured Earth, as did Iron Man 2. But things got a lot more interesting in 2011's... Thor features Earth, represented by America, alongside two other planets, Asgard, home of the gods, and Jotunheim, home of the frost giants.
Asgard is shown to be a flat disk rather than a spheroid, i.e. like a sphere, like all planets we've observed so far. Most planets are slightly oblate, meaning that they have an equatorial circumference larger than their polar circumference. Earth, for example, has an equatorial circumference of 40,075 kilometers and a polar circumference of 40,008 kilometers, meaning that the planet isn't a perfect sphere, but more of a squashed sphere, like a tangerine. The flattest spheroid we've discovered so far is a star called Achernar in the constellation of Eridanus, which is 64% of its equatorial diameter at the poles. But to achieve this flatness, it has to be spinning at 225 kilometers per second.
So a planet could conceivably be flat, like Asgard is shown to be, if it were very low density and spinning very, very fast, which is definitely not the case for Asgard. So, as it is shown, not even getting into the seemingly infinite supply of water on the planet, Asgard definitely could not exist without a strong foundation of magic.
Now those foundations are gone, sorry.
As well as Asgard, Thor introduces Jotunheim. Jotunheim seems to be a frozen planet made of ice, falling apart at the time of the movie due to a lack of magic. Hannah, do you want to talk about the role of magic in planetary physics?
No.
Okay. Taking magic out of the equation, then, Jotunheim is pretty similar to planetary bodies we've observed. For example, during the New Horizons mission, Pluto was observed to have mountain ranges made of ice, and other solar system bodies such as Miranda, Titan, and Ganymede exhibit cryovolcanism. Cryovolcanism is the equivalent of volcanic activity on Earth, but in places that are so cold that liquid water behaves like lava does on Earth. Volcanic features like lava flows, volcanoes, and eruptions have near-exact counterparts on icy worlds with liquid water instead of liquid rock. This would potentially explain several features we see on Jotunheim, such as these hexagonal columns, which appear similar to columnar-jointed volcanic rocks on Earth, such as the Giant's Causeway in Northern Ireland. For this theory to work, the planet would need to be extremely cold but Asgardians seem to be basically indestructible from an environmental point of view, so that doesn't seem to be an issue. Jotunheim is also shown to have a thick, water-filled atmosphere, which would cause extensive hydrological weathering and so could explain the features such as giant caverns which we see in the film. As long as Jotunheim was located far from its star, still maintaining a low surface temperature with a thick atmosphere, then it could definitely exist.
Surprise!
That's it for Phase 1, apart from a brief appearance in the Avengers of Sanctuary, Thanos' asteroid-looking home, which we see more of in Guardians of the Galaxy. This is an interesting one because we see features like Sanctuary all over the place in our solar system. Every gas giant in our solar system has rings of rocky or icy material around them. Most famously, Saturn has a large flat ring system. We also have multiple large asteroid belts in our solar system, so geologically, Sanctuary is absolutely possible. However, the density of material and the surface gravity shown in the films is much too high for a small body such as an asteroid, and because of this, the atmosphere on Sanctuary would definitely be too tenuous to breathe if it exists at all. That said, the MCU showcases artificial gravity technology on spaceships, and it's not exactly clear what the requirements are for Loki and the others' physiology. So, with some biological hand-waving and treating it more like a ship than a planet, Sanctuary might possibly exist.
Phase 2 of the MCU kicked off in 2013 with Iron Man 3, which again only featured Earth. However, things got a lot more interesting in Thor: The Dark World. Said no one ever. This film features 7 planets, of which we've already met Earth, Asgard, and Jotunheim, leaving Svartalfheim, Vanaheim, Muspelheim, and Niflheim. Svartalfheim is the home of the Dark Elves, a blasted planet with a thick, rolling atmosphere with tinges of orange. It also has a rather unique looking star. Every time it's shown, it's eclipsed.
An eclipse occurs when one astronomical object appears directly in front of another. On Earth, the sun appears eclipsed when the moon lines up directly between Earth and the sun. By some cosmic fluke, the sun and moon actually appear to be the same size in the sky on Earth. While the sun is 400 times larger than the moon, it's also 400 times further away. That means that the moon neatly blocks out the sun, leaving only a corona visible around the edges.
Svartalfheim seems to experience an eclipse permanently. That means that it needs not one, but 2 cosmic flukes. A moon that is the right size, at least approximately, and also that has a very particular orbit. In order for the moon to constantly block out the sun, it would need to orbit the planet at the same rate that the planet orbits the sun, such that it constantly appears in the sky in the same location as the sun. Even a slight mismatch of these orbits would result in the phenomenon being temporary. The odds of this happening are astronomically small, but the universe is a big place. We can't categorically rule out that it couldn't exist, so yeah, Svartalfheim might just be possible.
Vanaheim is an Earth clone, a terrestrial planet with temperate atmosphere and the extras from Game of Thrones sitting around. Nothing terribly interesting here, it's so similar to Earth that it could definitely exist. Muspelheim and Niflheim are only very briefly shown in the sky over London during the Convergence event, and there's really not enough to go on to rule on feasibility. Muspelheim appears in greater detail in Thor Ragnarok though, so we'll come back to it there.
We are briefly stuck back on Earth with Captain America, the Winter Soldier, before things go completely nuts in... By God, they actually learned how to make a nice looking movie. After Peter Quill is picked up from Earth, we're introduced to 3 new planets: Morag, Xandar, and Nowhere, which isn't technically a planet, but we'll roll with it.
Morag is the planet where Star-Lord picks up the orb containing the Power Stone, and seems to be very similar to Earth, but with several moons or other planets looming large in the sky. This may seem like pure fantasy, but we've actually observed planetary systems with planets so close together that they would appear this large in the sky. TRAPPIST-1, for example, is a star with 7 planets orbiting so close to one another that if you were to stand on the surface of one of them, other planets would appear in the sky overhead, even if only briefly during their orbits. We'll come back to this topic in a little bit when talking about another movie. Morag, however, very possible.
Xandar, the planet they paid Glenn Close to be on, is an Earth-like planet in a triple star system, that is, with 3 stars orbiting each other and, in turn, orbited by planets. Multiple star systems are surprisingly common, with our nearest stellar neighbour, the Alpha Centauri system, containing 3 stars. Finding a planet in a triple star system is less common, but in 2016, just such a system was discovered in the constellation Centaurus. The planet, catchily named HD 131399a, B, orbits 1 star, which is in turn orbited by a pair of stars. This unusual configuration suggests that planets with multiple suns may exist across the galaxy. So, Xandar? Very possible. That leaves Nowhere.
Nowhere is the severed head of a celestial avatar, an ancient being rather than a planet. It's so huge that it might as well be though. However, while it might be the size of a planet, it does not obey the laws of planetary science. If it were made of rock, it would have collapsed under the force of gravity and its own asphericity. That is how unspherical it is.
Planets like to be spheres, or spheroidal, accounting for rotation, because it's the way of combining a lot of rock together with the least possible potential energy. If a planet had a more complicated shape, then rock further from the center of mass could fall to a location closer to the center of mass, gaining kinetic energy. If everything is equally far away from the center of mass, i.e. a sphere, then nothing can fall anywhere. It's the minimal energy configuration.
Nowhere, however, is very much not a sphere, in that it's a skull, but as such it's made of some unspecified alien material that we don't know the properties of. And because we can't assume the physical properties will be like those of rocks that make up the planets that we've discovered so far, we can't definitively rule out its existence, citing how the rocks would fracture and fall apart into a sphere.
So it could exist?
Sure, why not?
Skipping over several films that again only feature Earth, taking us from Phase 2 to Phase 3, we find ourselves back with the Guardians in... And things are about to get a bit crazy. Guardians 2 features the most planets of any movie in the MCU, a staggering 12. We've already met Earth, but the rest of them are completely new. The first of these is Sovereign, which isn't a single planet, but rather a collection of planets that resemble Donald Trump's apartment, orbiting so incredibly close together that they cast shadows on one another.
While we saw earlier that Morag, similar to the TRAPPIST-1 system, could have planets orbiting close by, close enough to see, there's a limit to how close planetary bodies can orbit one another without tearing each other apart. Specifically, this is known as the Roche limit.
This is the distance from an astronomical object that a satellite, such as a moon, can orbit without being torn apart by tidal forces. Tidal forces are forces inside a satellite caused by a strong gradient in the local gravitational field. The side of a satellite closer to the object it's orbiting will experience a stronger gravitational pull than the side further away. Because the satellite isn't a single solid object, this will act to pull the satellite apart. Far away from the object it's orbiting, this will be a negligible effect, but get close enough, go past the Roche limit of the object, and the satellite will be torn asunder.
Assuming that the planets comprising Sovereign are made of the same material, and so have the same density, the Roche limit is given by this simplified equation. In other words, if a planet is orbiting another larger planet in Sovereign at a distance less than 1 1/4 the radius of the larger planet, it will be inside the Roche limit. That is definitely the case for the planets shown here, and so they are too close to each other to exist in a stable configuration. So the planet system could not exist as shown.
Yeesh. After leaving Sovereign with the Harbulary batteries, the Guardians are pursued through an asteroid field with a bit of quantum mechanics thrown in. The quantum asteroid field appears similar to the asteroid belts that we have in our solar system, but the asteroids are blinking in and out of existence. We've never seen anything like this, and for good reason. Quantum mechanics is the fundamental theory explaining some of the smaller scale interactions in the universe between fundamental particles like electrons and photons, and a key component of the theory is the randomness inherent in physical systems, known as quantum indeterminacy. The quantum asteroid field exhibits indeterminacy in the position of each asteroid. One moment an asteroid is here, the next it's there. There is a major problem with this, however, and that's the size of these asteroids. Quantum mechanics applies on small scales, such as when you're describing individual atoms. Describing objects larger than atoms results in quantum effects being lost as the object interacts with its environment, a process called quantum decoherence. Think of it like this. Quantum effects are lost over time as an object interacts with its environment in much the same way that energy is lost in a mechanical system due to friction. The larger the quantum object, the faster quantum effects are lost. Like in a system with a lot of friction, energy is lost very quickly. So while a quantum object exhibiting indeterminacy could be as large as an asteroid, it would not stay a quantum object for more than a fraction of a second. As such, the quantum asteroid field could not exist as shown. Which is a shame because it looks bloody awesome. After this, the movie features a baffling array of planets, some of which we learn very little about because they only feature on screen for a few seconds. So, quickfire round. Bearhurt, the planet where the Guardians crash.
Basically an Earth clone with 4 moons. Seems possible to me.
Contraxia, the icy planet with a sly cameo.
A terrestrial ice planet, much like Hoth in Star Wars. Actually, go check out our video on planets in Star Wars for why that one could exist.
Isik, where Ego starts some aggressive expansion.
Honestly, too little information to go on.
Arago 7?
Same problem.
Hala, which first features in this film and then more extensively in Captain Marvel as the Kree homeworld.
An Earth-like planet. Again, we have so little to go on that there's nothing to suggest it couldn't exist.
How about Rhea?
Okay, this is an interesting one. In the clip we see a murky atmosphere and some aurora, which are orange rather than the blue, red and green we see on Earth. The colour of the aurora on a planet is due to the chemical composition of its atmosphere, almost entirely oxygen and nitrogen on Earth, which gets excited by energetic particles from the sun, which causes the aurora. Orange aurora would be possible if the atmosphere on Rhea was comprised of calcium gas. Calcium is one of the most common metals in the universe, though it's not a gas that we see in large concentrations in exoplanetary atmospheres. It's a rock-forming element rarely seen on its own, so unless calcium was being outgassed somehow through some unknown chemical process, I'd actually go with not possible on this one.
Okay, so what about Akon?
Akon has some funky-looking pink vegetation, and it orbits a blue star. This is most likely an O or B type star, which are some of the hottest and fastest live stars in the universe. The whole live hot, die young thing really started in the stars. The question here then is, would there be enough time for complex life to evolve on that planet? Considering that the star doesn't have a long life cycle and the planet would be bombarded by strong UV and X-ray radiation from its star, way more than we have here on Earth. For Akon to be habitable as well as evolution happening quickly, the atmosphere would need to contain strong UV and X-ray absorbers, similar to ozone in the Earth's atmosphere. This could shift the peak wavelength of the stellar light to the red, so you might result in redder looking vegetation. So I'd say it's plausible, but a particular string of requirements must be met for this to work. Still though, possible.
That then leaves Ego's planet, which is, well, it's a planet that's also a person who's a god.
Small G, son.
Surface gravity aside, this one is outside of our expertise and firmly in the realm of fantasy. So much like with Nowhere, we'll have to concede that with some celestial materials, it could possibly exist. After the madness of Guardians 2, we briefly return to Earth in Spider-Man Homecoming before heading over to possibly the weirdest planet of all in Flash Thornton. Sakaar is a planet made of trash. The planet forming from the excretion of lots of portals, most famously the Devil's Anus. Well, there's a sentence I never thought I'd say.
The material's different, but the gradual accumulation of matter is exactly how one of the ways that planets can form. Planets form from sticking together rocky material, initially dust and then later rocks and larger planetesimals. This is the material left over from the formation of a star. Sakaar seems to be the end result of the same process, but instead of being accumulated dust around a star, it's the central point of rubbish shot from wormholes in otherwise empty space. The film seems to show objects travelling out of the portals at low, i.e. collisional speeds, which would result in sticking together rather than shattering on impact. Over time, the garbage from the portals would most likely form a planet of some kind.
There are a few questions though. Sakaar experiences both day and night, which implies that it rotates near a star, yet this isn't clearly shown in the film and isn't implied by the Disneyland ride Thor goes on. Maybe Sakaar is actually a layer of garbage on top of an existing small planet around a star? Perhaps the Grandmaster isn't totally reliable as a narrator. In addition though, a nearby star would subject Sakaar to harmful radiation and energetic particles that we are shielded from on Earth by our planet's magnetic field. That magnetic field is created by our planet's molten iron core. It acts like a giant magnet. If Sakaar is made of trash, then it's highly unlikely to have a strong magnetic field unless the metal pieces of trash that landed there all sank to the core of the planet and formed a molten layer, which would potentially generate a magnetic field. Perhaps the portals also have a magnetic moment? But additionally, the atmosphere of the planet would be the result of outgassing of the material that collected there. It would be a concentrated version of the air inside rubbish dumps, minus the oxygen. While it would have an atmosphere, it would be incredibly toxic and quite possibly extremely flammable.
Smell. What does it smell like?
Bent toast.
So a trash planet like Sakaar could physically exist, but it definitely wouldn't be habitable. And so without getting into the weird flow of time on Sakaar, we're gonna have to say it couldn't exist as shown.
What?
We're not done with Thor Ragnarok yet though. We've had Jotunheim, we've had Svartalfheim, we've had Niflheim, and now we have Muspelheim and Anaheim. Wait, no, sorry, Hell. Hell is actually only briefly featured and appears to be like Earth, but with a thick atmosphere and slow motion, so it seems very possible. Muspelheim, on the other hand, actually looks like Hell, somewhat confusingly.
It actually looks just like Earth during the Hadean period, which we also covered in our Star Wars video. However, given we're dealing with an Asgardian, Thor, the point about habitability in that video doesn't really apply here. The geology scene in the movie is also very similar to volcanic regions on Earth, with volcanic columns as seen for example in Fingal's Cave in Scotland. So both Hell and Muspelheim could really exist.
Skipping over Earthbound Black Panther, that brings us up to Avengers Infinity War, which is largely set on planets away from Earth. We've already covered Nowhere, but the others are new to us. Vormir is the planet where the Soul Stone is kept, and probably the most visually striking world in the MCU.
In the sky of Vormir, we see another eclipsed star with an extremely active corona. Jumping ahead to Avengers Endgame, it isn't a spoiler to say that the star is still eclipsed in another scene set on the planet. That implies that the star is also permanently eclipsed, like Svartalfheim. Oh, I don't know how to say that name. Again, this would be possible if Vormir had a moon with exactly the right orbital parameters, and it's implied in this one shot that it possibly has two moons, one with an atmosphere. In fact, the ring of fire surrounding the other moon may well be a backlit atmosphere. By the same process that turns sunsets on Earth reddy orange, the starlight would be shifted to the red by passing through the atmosphere of the moon.
There is a lot to unpack in this screenshot though, from the cosmic horror on the left, what is that? To the gas cloud reaching the surface at the planet's pole, to the beam of energy coming in from the left. The only thing we've observed that resembles this is a beam of energetic particles known as an astrophysical jet, fired out of the poles of massive rotating objects such as black holes. For the beam to be this tight, however, the planet would need to be in the immediate vicinity of a supermassive object, otherwise the beam would be much more spread out. Being in the immediate vicinity, however, would render a delicate balance of orbits, as the moons would need to constantly block out the sun, impossible. So Vormir could not exist.
Reality is often disappointing.
Nidavellir, or Nidavellir, as Thor says it, sounds like a made-up word. The home of the dwarf giant Eitri is a stellar forge.
I mean, that place is a legend. They make the most powerful, horrific weapons to ever torment the universe.
This is neither a planet nor a star, but a huge structure entirely surrounding a neutron star, which is in turn surrounded by several rings. It's an example of a Dyson sphere, a hypothetical structure that encompasses a star and captures its power output, in this case to power a forge. We don't want to dwell on this design of the forge too much, or how it would operate. Instead, we're talking about the feasibility of the physical structure here. And much like Nowhere, we don't know what sci-fi materials this structure would be made of, or how responsive it could be to small-scale changes in gravitational field of the star that unchecked, could tear the sphere apart.
Or for that matter, how it would deal with external forcings like being hit by debris or asteroids.
So assuming those problems are dealt with, this is a tentative, hypothetical, maybe possible, given some incredible sci-fi technology. Spherical symmetry is really lending a hand here, but definitely beyond us humans for the foreseeable future.
You people are so petty and tiny.
That leaves Titan, the homeworld of Thanos, where a lot of the action in Infinity War takes place. Somewhat confusingly, this is not the same Titan that we have in our solar system, the moon of Saturn, which is on its own super interesting. So we shouldn't compare the planet as shown to that moon. What we do know about the planet is what Star-Lord says upon arrival.
What the hell happened to this planet? It's 8 degrees off its axis. Gravitational pull is all over the place.
Star-Lord says this as if it's incredibly unusual, but Earth is 23 degrees off axis in our orbit. This tilt is what causes the seasons.
It's not clear how a planet being 8 degrees off axis would have the dramatic effects that we see on Titan compared to what Thanos shows us it was like before. In fact, 8 degrees is fairly small when we look at our solar system planets, where the Earth is tilted to 23 degrees, and Venus is basically spinning backwards and upside down with a tilt of 177 degrees. What this could mean instead is that the planets experience a rapid axial precession angle of 8 degrees, essentially going from tilting in one direction by 8 degrees, then the other by 8 degrees in a circle, like when a spinning top is not perfectly straight and it tilts one way then the other in one rotation, drawing out a circle on the tabletop. If the planet's doing this quickly enough, it would cause some dramatic effects on the internal dynamics of its liquid core or mantle, which in turn could cause twists in the magnetic field and changes in the gravitational field that would be chaotic.
I'm going to say this straight up though, without a supercomputer, we really don't know what effects this would cause. It's a really complicated problem to solve.
The Earth actually also has an axial precession, but it's on the order of 25,000 years, which is very long and will not cause any harm to Earth or us. It just changes the seasons a little bit over a long time. So if we ramp up axial precession to 11, caused by some unknown event on the planet, maybe irresponsible geothermal energy harvesting, Titan could exist, but I am speculating wildly.
That's not it for Infinity War though, as the very last scene of the film is Thanos on Titan 2, otherwise known as the Garden. This is a pretty standard Earth-like world with some large moons, and as seen at the start of the Endgame, a ring of matter around it, similar to Saturn. While we associate rings with the large planets in our solar system, it is possible for terrestrial planets to have them too. The dwarf planet Haumea, orbiting outside of Neptune's orbit, has both moons and a ring of material. So with this precedent, and otherwise being like Earth, the Garden is very possible. Man, after you examine a planet literally made out of garbage, everything else seems so banal.
Are you yawning?
Skipping over Ant-Man and the Wasp, we come to a final new planet in Captain Marvel. As we previously said when talking about Guardians 2, Captain Marvel features Hala, the homeworld of the Kree, as well as Earth and new planet Torfa. Torfa is an Earth-like planet with a thick, dusty atmosphere and blue soil. A thick atmosphere on a terrestrial planet is very possible, and the orange colour of it would make sense if the atmosphere was denser than the Earth's, perhaps as a result of more extensive outgassing from more active plate tectonics or volcanoes, for example. The blue soil is an interesting one. It could be the result of microbial life such as cyanobacteria, or it's simply a result of being rich in copper. Copper turns blue when oxidized, and when bonded with ammonia, it creates a deep blue compound called amine. So our final planet Torfa could exist.
Congratulations to you, Star Force lady.
That means then that of the 28 planetary bodies considered in this video, 3 we just have too little information to go on, 6, Asgard, Sovereign, the Quantum Asteroid Field, Rhea, Sakaar, and Vormir couldn't exist, and the rest are possible, to varying degrees. Looking at you, Svartalfheim. While pretty wild, the planets of the MCU still only scratch the surface of what is possible. In our last video together, Hannah, you talked about hot Jupiters and how you'd like to see more of them in science fiction. What are other possible planets that we still haven't seen in sci-fi?
There are so many different planets that are left to explore. Planets with their atmosphere being stripped off by their stars, Water worlds with atmospheres of steam, or planets with solid ice crusts and deep water sub-oceans? What would life be like on the moon, like Enceladus, for example, in our solar system, which is liquid ocean between 60-kilometer ice sheets? What about a giant ring system with blocks out the star periodically, causing varying day-night eclipse cycles on the planet? What would that do to life then? A tidally locked planet with a permanent day side and a permanent night side, something which is very common in our most studied exoplanets. Ooh, clouds made of rubies and sapphires. Okay, I'm going to stop.
Don't worry, Hannah.
I could do this all day.
In this video, we drew on concepts from quantum mechanics, orbital mechanics, electromagnetism, and atmospheric physics. If you've always wanted to learn more about these topics, then the best way is to solve practice problems. But where to start? How do you find good problems with clear explanations of the subject matter? The answer is educational website brilliant.org. Brilliant has dozens of courses written by experts across maths and science, which are enjoyed by over 7 million users. You can study all of the topics we introduced in this video and beyond. In particular, if you enjoyed the discussion of quantum mechanics, then you should check out their excellent course on quantum computing. I wish that I'd had access to Brilliant when I was at school. The website makes an excellent companion to study at senior levels, as well as a standalone educational service for curious adults. Their offline courses in their apps for iOS and Android make learning a little bit each day through practice problems on your commute or in your lunch break as easy as pie. Sorry. To get smarter at maths and science, go to brilliant.org/Simon Clark. And the first 200 people to use promo code Simon Clark will get 20% off their premium annual subscription. Thank you for watching this video. It has been a real labour of love over several months. And huge thanks must go to Hannah, to Dr. Wakeford, for her endless enthusiasm and expertise, and frankly, patience with me. So thank you, Hannah. Also thank you to Dr. Thomas Preston, who gave a consultation on the quantum asteroid field. If you found this video interesting, then definitely check out our previous video on the planets in the Star Wars films. And if you'd like to see behind the curtain, or if you'd just like to support my work, then you can do so on my Patreon. There is an extensive behind the scenes video outlining how I made this, how we researched this video. Thank you so much for watching to the end, and I'll see you in the next one.